We're going to go further than that. We're going to make it a problem on your side. We're going to use free microwaves, free microwaves as much as we can possibly muster. Put shields of energy out that 1,000 or a million drones up against a shield will all fall susceptible to our system.
All players, low down, active, bullseye, 1327, for tactical. Lights on.
Welcome to The Merge, where we make sense of defense in an enjoyable way. I'm your host, Mike Benitez. Today is something that's been on our list for a while. It's been something that you guys have been asking for. Well, guess what? You asked, we delivered. Today, we're going to get smart on the next generation of defensive systems, directed energy weapons. Specifically, we're going to be talking about high-powered microwave systems, HPM. That'll probably be the last time you hear us spell out high-powered microwave today. HPM is the phrase of the day. Microwave weapons, it sounds like something straight out of a futuristic novel or science fiction. It's not science fiction, it's science fact. It's here, it's real. And to help unpack this, I went straight to the top. So I am joined by the CEO of Epirus, Andy Lowery. Welcome.
Thanks, Mike. Real pleasure to be on and telling the audience a little bit more about directed energy.
Now, I've been tracking Epirus for just a bit because it's been on my list for a while to get you guys on the show. But for someone who has no idea about the company, we can start with the company and then we'll get into the technology.
Yeah, sure thing. The company Epirus is configured in what they call a non-traditional defense contractor. We're in that group. And what that means is that we have private side investors that started the company up a few years ago, about 5 or so, 6 years ago, where the private side investors foster care, if you will, these companies as they're building a capability for the military that they may need. And then over time, the idea is that you move from the foster over to kind of an adoption, and the DoD adopts you as one of what they're calling a non-traditional prime. And prime contractors today, there's only a few, maybe a half a dozen, 6 or so. And that presents a bit of a problem, a challenge, if you will, that a lot of times the warfare you see today is what they call asymmetrical, or sometimes it's called irregular warfare. And what that means is that there's been a movement towards warfare about starting to incorporate 3 particular elements into kind of the way battles are being fought. One, you see a lot of countries heavily leveraging consumer electronics. So they're just not needing to invent anything. They can click things together very quickly. They can produce things in volume very fast. That's one. 2 is they're highly distributed. So a lot of the threats that we're talking about today are highly distributed, like drones, like USVs on the water. And then the last is they're highly networked. And so that's the way that future battle, or today battle, I should say, is being fought, is through highly networked, highly distributed, and highly consumer electronics leveraging systems. Now, we need a defense contractor that is built to counter that threat, that can move with the same speed as the speed of electronics, that deeply understands distributed platforms that leverage networks and how to defeat those things. And that's by taking basically the best in breed out of defense companies and marrying them with best in breed out of the best consumer electronics companies, like Amazon, for example. Our chief AI officer hails from Amazon, where he ran a big portion of their AI portfolio. And by taking those various elements and bringing them together, we have built a company that's highly, highly able to counter those emergent asymmetrical irregular warfare threats. So if we see the trend continue, we'll only see more and more asymmetrical irregular warfare types of applications. We're the defense contractor to counter those new warfares that you're seeing emerge. So that's what Epirus does at its core, at its heart. We're patriots, but at the same time, we like to move fast. We like to deliver products ahead of the need. And that's kind of the mixed difference, if you will, if you look at us versus a traditional prime.
I haven't actually ever heard it phrased that way, the 3 things. So it was the consumer electronics, distributed, and then networked together, right?
Exactly. And you think about, like, if you go back best technology started with the military. I mean, it started with DARPA, you know, the internet and this and that. Nuclear power was my old buddy, Admiral Rickover. This all came out of the military, all these really advanced ways of bringing technology. Now, that's changed in recent years. I mean, that's changed, and that was built by an infrastructure of consumer electronics, and that's largely leveraging chip-level type systems like Qualcomm and NVIDIA and Intel. They build systems on a chip that make it very easy to engineer different applications around drones and robots and computers and phones and head-up display goggles and VR goggles. They're all built around that same core engine. And so those core engines can be easily bought in quantity and volume and repurposed to do this or that, to build almost any sort of piece of consumer electronics gear that one would want to build. And then you look at all of the different sorts of consumer applications that these consumer electronics are powering, and they're always social media, highly distributed, highly networked, right? Military is thinking about security, safety, like let's not make a big network that gets everything all out. Well, the consumer folks didn't have that restriction. They said, let's go out, let's do it. Let's make these very robust, distributed network type systems. Now, the application of those same tools and those same elements are what's fueling the warfare we're seeing in Ukraine, what will be fueling the warfare we see in Israel. It's fueling those warfares. The networked, distributed, consumer electronic leveraged systems are fueling those wars we see today. We're weak. I'll say it. We're weak when it comes to asymmetrical, irregular warfare. SOCOM is really good at what they do and all this and that, but as a nation, we need to prepare ourselves by building in not only Epirus, but other companies that can bring in sort of knowledge of consumer networks, knowledge of distributed things, knowledge of consumer electronics, and build counter systems to those systems.
Yeah, I'm glad you said asymmetric. So asymmetric strategy basically means you're playing your strength directly against the point of weakness of your opponent. I wrote something in the Merge probably a couple weeks ago, a month ago now, about cost imposition strategies. And that's what happens when you are at the weak point of that. And there's this ridiculous cost imposition where the cost of inflicting harm is pennies on the dollar, and the cost to defend against that harm is dollars on the penny. And you mentioned like the Houthis in the Red Sea, the 300 plus airborne attack from Iran against Israel. And like, yes, that was 99% defended, but it's definitely not repeatable. And then you look at just the magazine depletion and just the cost to replenish that and have to position the resources. It works, but it's a very reactive tactic. It is not a proactive strategy. So to your point, the way that you solve that asymmetric problem is you address the weakest points that asymmetry is happening. And so you develop your own systems to counter that. And then it just becomes symmetric warfare. And if it's symmetric, that is how you build deterrence, which then is how you prevent conflict in the first place, right?
You said it better than I could have said it. That's exactly poetic. That was poetic. It's absolutely what's happening. And to that point, you see certain programs DoD's implementing, like Replicator, for example. And Replicator, I'm not sure, does what you just stated, right? Replicator is more of a me too. Like, how do we keep up? How do we not deplete our big, expensive missiles? And it's not, cost equation something, but it's also, like you said, it's magazine depth. If we need a missile to take out a drone, there's just no way. Our manufacturing capability and capacity will never, ever, ever get to what China can build in drones. They will just outbuild us every day of the week and send these low impact but high volume, highly distributed swarms of drones, for example, in over enemy lines, forcing us to spend $1 billion and, more importantly, deplete that very effective big missile arsenal out of the way. So now they can send in their big missiles without anything to stop them. So to your point, one is we have to fight this battle as it's being presented to us, but we can't fight it with a Me Too solution. This isn't going to be, oh, let's really quick catch up with everything that China's done for the last 40 years. I mean, it's just impossible to build at the scale of what they can build at when we're talking consumer electronics. But what we can do in the United States, and what we are doing at Epirus, we can put it on its head and say, no, we're not going to answer with a me too. We're going to use the best and brightest engineers we have out of Raytheon, Northrop, but then Amazon and commercial type companies, merge them together, highly motivate these groups of folks, young men and ladies, to be state-of-the-art engineers, and then upend it completely. We're going to not only take out the cost equation issue, we're going to go further than that. We're going to make it a problem on your side. We're going to use free microwaves, free microwaves as much as we can possibly muster, put shields of energy out that 1,000 or a million drones up against a shield will all fall susceptible to our system. I think you're going to see a lot more of advanced electronic warfare and new forms of electronic warfare like HPM, which in all sense of the word should be viewed as a new leg of the electronic warfare stool. It should be looked at as a new leg. If you look at what we're doing in HPM, it's very akin to cyber and a cyber attack through an analog susceptibility on the analog side of these systems. So these consumer electronics come out very susceptible to different types of waveforms and techniques. They're wasting their time and their money building consumer systems that we can knock down at a penny a shot or 10 cents a shot or something like that.
So two things. That was like your perfect segue. So you said you kind of threw out casually $1 billion of weapons. The Navy in the Red Sea has spent over $1 billion in weapons shooting down drones in the past 6 months. That's incredible. $1 billion. That's B, a billion with a B in weapons expended shooting down drones in the Red Sea. And there was a recent hearing. I don't know if you saw it with Senator King. He had a really good talking point on one of these oversight hearings to make a point. He says 3 numbers: $10,000, $4.3 million, and $12. And he said $10,000. That's the high end estimate of the cost of the drones that Iran and the Houthis are using. 4.3 million. That's the cost of a single SM-6 missile. And they said $12, the cost of an average directed energy shot that can take down some of these drones. And I think maybe that's even on the high end. I've seen it down to, $2 or $3 even. That's the good segue of let's talk about microwave weapons. And I really want to let's start with a microwave. I know that as a frequency in frequencies and measurement of wavelengths. Some other people think of it as home and appliance in the kitchens. So for someone who doesn't know the difference between them, how would you explain what is a microwave?
So energy is wireless. Energy just transmits. You have light energy from the sun. You have low frequency energy from a radio tower. You might see this large antenna. You see all of the cellular boxes that sit up in the sky, and those are all a certain frequency. Each of these devices put out a certain frequency, which means a certain wavelength. So literally how long a sine wave will take to go from A to B, plus how many iterations per second. Like your wall might give you 60 hertz. That means 60 times a second. When you talk 1 gigahertz, you're talking giga, so 1 billion times a second. So you can relate time to frequency on number of cycles, or like if you think of one wave being one up peak to one trough. And a microwave band is a certain band. There's a gamma ray band, there's X-ray band, there's light wave band, and then there's a microwave band. And the microwave band includes, and why they call it a microwave oven, includes the type of waves that your microwave uses inside the oven. So within the band of frequency called microwave includes that oven application, but very different than what we do, differently built and differently run, and it does a different job.
So you're saying you can't like rip the door off of your microwave oven in your kitchen and just point it at a drone? That's not going to work?
Yeah, it's funny you should say that. I think in the early days, someone told me a rumor that they were trying that in the early days of Epirus when they had like 2 guys and no money. And they were like, well, let's try to Jimmy open the door and see if it won't knock a drone down. And so it's funny because, it is something that could be plausible. It could be plausible, but it wasn't exactly the right type of energy. And so it doesn't work well. It doesn't work well.
So you mentioned that, the past 5 or 6 years that Epirus has been working on this, and your core product line is called Leonidas. Before we get into that, there's got to be a connection with like the Greeks, right? Like these words have a connection. What is the backstory of the naming convention of your core product in the company?
There's a movie out there called Immortals, and some of the younger guys were looking at that movie and they saw this bow that I think Thaddeus was pulling back. And every time he'd pulled a string back, an energy arrow would appear infinitely. He would never run out of a quiver of arrows. So he had an infinitely deep magazine, if you want to think about it that way, where he can always pull a new arrow. And Epirus is the name of that bow that shot the infinite arrows. And then when they began to name the other elements of the company, they said, well, let's pick some other names that leverage Greek and Greek history and a lot of our conference rooms and all of that. And so when they picked the product name, Leonidas, they thought of that scene in that movie 300 from the Spartans and the Persians and when they were at war. And what the rumor was, and the movie depicts it, is that they brought in 1 million people. And Leonidas, with his small group, only had 300. And that's the name of the movie, 300. And it's King Leonidas. And so to be able to defeat a 1 million-man army with just one little group of people, kind of outthink, out-tactic, out-technology. And we thought, what a good name for our system. Because think about it, you could put 1 million drones, not army men now, but drones these days, 1 million drones in the sky, and still Leonidas won't bat an eye. We'll put energy up, we'll shield against it, and all those drones will come a-tumbling down. And that's why we thought about Leonidas being a pretty good name for the system that's built by Epirus.
Oh, that's a great story. I always try to ask people when I have them on the show, like, where do these names come from? And there's always a really fascinating backstory. And this makes sense now. The Epirus, the movie with the bow with the endless amount of arrows, is this why the company's logo has the arrows coming out of it?
Yeah, that's exactly right.
Okay.
More and more, we're getting compared to what's called serial killers, which are like arrows. They shoot one laser for one drone or one kinetic missile to one drone. And our system is a real parallel system that can put energy walls up, or shields or walls, however you want to look at it, that occupy a volume in space. So if you have 1,000 or 10,000 drones in that volume, they all get affected by that volume of electromagnetic interference energy that we're putting up in the sky.
So what you're saying is you're not a serial killer, you're a mass murderer. Maybe that's not the analogy we should use.
I think the metaphor better. I like the metaphor if you know Star Trek and you've got the USS Enterprise, the spaceship Enterprise, and it has two things, right? It had photons, which are like lasers. Yep. They shoot way out a distance and go one single photon against one single target. And then you had shields. And the shields would come up when you had a whole host of targets, a whole swarm of targets coming at you to try to hit your ship. This is our first soiree as a civilization, as a human race, into building shields of energy, literally electromagnetic shields of energy, which makes it a very cool place to work at.
Yeah, that's cool. All right, let's dig into Leonidas. I was looking at the research, and it went from I think the first product rollout, like literally rollout. It was a Toad. It was a Toad platform. Was like 4 years ago, right? So it's only been around for 4 years. But man, I was looking at the contracts and just the progress, and I saw the recent milestone with the Army. It just completed developmental testing for the first 4 prototypes. So delivered and completed testing at the same time. So congratulations for that. That is wicked fast in defense, and it's wicked fast defense hardware-wise.
Yeah, well, that's the advantage of being a non-traditional defense contractor. I mean, you have a group of investors that place your initial kind of working capital in. Now, you can't rely on that forever. We have to build a high top and bottom line, important bottom line, robust business that puts out profit so that we can reinvest that profit in, as our investors are doing today. But what it's allowed us to do is it's allowed us to get started with a lot of the clever ways that you can increase your velocity, right? Because we have to be hyper fast. We have to be faster than the military could ever dream of being. The Air Force today said, could you build us something in 18 months? And we said, oh, sure. Like 2, 3, 4 in 18 months, no problem. I mean, it has to be almost like a ridiculous time frame on their side as far as speed goes. They have to think of it as we have to move at the speed of technology as a new type of prime contractor. And we've gotten initial investment to help us with that, but we build into the way we engineer the best of breed of commercial mixed with best of breed of DoD. So we do a very iterative prototyping. We buy a lot of inventory and hold it in our warehouse ahead of time so that we can be quick to react and not slave to the supply chain times and things of that nature. We interview and we go out to our customer. We do soldier touch points. We are very involved in the user experience. And then we bring all that knowledge back and we invent ahead of them coming to us with requirements, because we know that they're going to want this, that, the other thing. And so we build in advance of that need and then show up and say, hey, we've gotten this or that. Maybe not a done system ready for IOC, but pretty far along the way. And that allows that collapsing of the time that the military can now do. They can use the adaptive acquisition framework and other types of things like we call an MTA, a mid-tier acquisition, in order to shorten the time we get to IOC. But they wouldn't be able to be successful with a traditional defense contractor in this way, because it takes them time to get it, build it up, because every little thing has to be more or less scoped out by the DoD, more or less. I mean, this is a little oversimplification. But with us, we don't want the scope. We want to get out without requirements. We want to get on moving without any of that, building our own ideas and our own system in a very quick way. And so far, that's proven out. That's proven out to be what you see today. It's like we timed it right, and we got the right problem at the right moment with the right level of support and the right team to go deliver. And that's where we sit today. So Epirus is in a great position to be a successful company in the experiments that Ash Carter really started when he started this whole idea about the adaptive acquisition framework.
In my day job, I am a director of product at a tech company. And a lot of the things that you're saying, did you used to be a product manager before, early on in your career?
Yeah, I have 3 10-year careers.
So you did work in product development.
I did. It was one of my 3.
Being a product guy, you have to, predict the future, forecast the needs,
That's right.
Go out and meet the customers where they sit. And man, like what a great, you have a CEO of a defense tech company who used to run product-led development. Going after my heart here,
I've been a military user when I was a nuke in the Navy. So I've used the equipment and I've been responsible for maintenance, repair, and operation of those systems. That was 10 years. And then 10 years, I worked in big defense. I worked at Raytheon, and I understand very much how Raytheon can deliver systems. Next Generation Jammer was one of my credits to my career that I bid that and won that in 2012, 13 time. And ended up running that business for a couple of years until I went into my next 10 years. And my next 10 years was startups. And this is my 3rd startup now. My 2 previous ones were in pure consumer electronics, right? B2B, it was industrial application, but it was head-up displays, augmented reality, see-through type displays that you could wear while you work and have hands-free. And it could be used in the military, but obviously used in oil and gas and other industries. So that was a very consumer play, like 100% product play. And I realized really the differences in my 2 previous startups between a product approach and a services approach. Go anywhere in the world, and there's 2 places that I know of that when you go in day one for your job, they're going to say, go find a charge number. And that's a law firm and a defense contractor. As soon as you can't find a charge number, you'll be looking for a new job. Okay? That's just indicative of how a services company works. They say, we've got this much services. We charge to these services. What do you want? We'll do anything. Raytheon will build you a radar, weapon system, missile, doesn't matter. Whatever the DoD wants, we're here to build. So they end up becoming an outgrowth, really, of the DoD. We want to maintain a bit of independence and not be so coupled to the DoD as a non-traditional defense contractor. And so we bake into the DNA of our organization a product approach that marries well with 10 or 20% of services, right? So we do 80% product, 20% services, and that kind of marriage allows the customization of our systems for a DoD application, which is always going to be required. You're never going to guess 100% right on something as complicated and game-changing as the Leonidas system is.
All right. It's game-changing, not just as an HPM, but it's got some magic going on inside it. And the one that I think that I'm familiar with was Thor. That was a Air Force research project. It went on deployment a couple years ago, and then it kind of, disappeared. This is not the same as that, though.
Yeah, it's hanging around. And in fact, a high-powered microwave in sort of an older form with big dishes, big parabolic dishes, they look like satellite communication antennas or something like that, with a small feed on the front of it. Those have been traditional high-powered microwave systems, and they've used older technologies like traveling wave tubes or vacuum tubes in order to build this tremendous amount of energy in one singular pulse. And then they focus it as tight as they can as a beam to get it as far as it can in order to put enough electromagnetic interference in the atmosphere to knock it down. Now, that's the old way of doing it. The new way, if you look at the Epirus way, is by taking what's called a phased array. And there's plenty of technology out there in outer space and even on the ground with different sorts of radars like the SPY-6 radar, a number of others that are what are called phased array. Now, when you look at our system, it's a little less like a Thor and more like a next generation jammer. And that high-powered EW system, one was solid-state based, NGJ, as is Leonidas. We both use what's called gallium nitride, which is a new type of semiconductor that's been around for just about 20 years, which in the history of semiconductors isn't a long time. And it's able to do things that silicon will never, ever be able to do. And the advancement and the uptake of that has led to a lot of majorly powerful systems that haven't ever been able to be as powerful as they are now, like next generation jammer or now our Leonidas system.
And we'll put a picture here if you're watching on YouTube. When you look at this, it looks like a ground-based ESA radar because it's got that aperture. From the fighter community or guys who are familiar with fighter jets, the F-22 was the first one with an electronically scanned array. So the radar was fixed and it used electronics to steer the beam, and it allowed you to do all kinds of cool stuff with it. So you could focus the beam, you could split the beam, you could track multiple targets at the same time. Now there's gallium nitride going into fighter jet radars. That's hitting the street in the next 2 years or so. There's two of them that I know have been in development. Pretty fascinating. And to your point, the ground-based radars, those are all going to gallium nitride. Seeing the Lockheed one, the Raytheon, they're all moving to that. And you're basically saying like, yeah, it's time we can use the gallium nitride electronically scanned array as our aperture.
Think of them like the new headlights that come in all the new vehicles people are familiar with. And you look inside and you see 100 LEDs or maybe 20 LEDs, and they focus them into a single beam. They focus them all up. But you'll notice something. When you go around the curve, those LED lights will lead the way. You'll go turn left and it'll point the beam over towards where you're starting to go. Well, that's how our system works. It has a whole bunch of little microwave elements in it, and it can steer that beam around at a blink of a second, like at a microsecond of time. It can move that beam anywhere where it can steer it in its whole field of regard. So 60 degrees about, it can scan anywhere in there at a blink of an eye. And by doing that, basically shield an entire area of the sky with this electronic microwave energy. So we're using a solid state, which allows for a lot more different pulses of different types, of different frequencies, of different pulse widths, of different duty cycles, mixed with a software-defined backend and a highly, highly powerful transmitter that Epirus has become known in industry as being the transmitter people. We know how to take a transmit chain and just make it sing. Because a lot of times you can get the gallium nitride and stuff, but if you don't know how to control the gallium nitride, you'll run into troubles where the thing will just self-destruct. I mean, if you think about it, we're creating with an electrical machine enough electromagnetic interference energy to disrupt things far, far distances away, many football fields away, up in the sky. If we were to not know what we were doing, that energy would just self-destruct our system almost and jam our own system as we're building it. So we're looking as that as sort of like our speciality, is those transmit chains. So we've built a number of systems, as you know, and we're on basically our 4th iteration, but that's the general way it works.
So you basically have consecutive leaps of technology all kind of coming together and intersecting in this product. So you have this next generation gallium nitride phased array on the front end, and on the back end, you have solid state devices and software defined weapon system, basically. So be able to adjust your techniques. So they're not hard programmed, right? You can respond to a threat and adapt based on what's going on. I'm sure you have a certain like playlist of techniques that based on what you know, but like you said, it's consumer electronics. You encounter a drone that people have adapted and you haven't seen before. How does your product deal with it and kind of cycle to adapt to it in those technology cycle times that we're talking about?
I kind of gave you the system view, how the system kind of works. But now if we drive down deep into the waves of the energy, how does those electromagnetic pulses, if you will, those directed electromagnetic pulses actually take down a drone? How do they stop a drone from working? It's really pretty fascinating because it's very similar to modern high-powered electronic warfare, but there's a key difference. Modern high-powered electronic warfare goes through the receiving side, the antenna that's there just out there in the world, and it's trying to suck up energy at a particular frequency. And what a high-powered electronic warfare system will do will go through that antenna, it'll get mixed up into the digital part of the system, and then it'll perform some sort of effect on the analog side. Whereas what high-powered microwave does, and especially in the way that Epirus is implementing it, is it kicks in the back door. It's a backdoor technique. It doesn't come in through the antenna. It goes right in through cables and wires and other things like that. It just gets absorbed by the actual electronics themselves. Like they don't need an antenna sticking out. We push the power to such a high level that we push the power right into the electronics themselves. But once they get inside the analog portions of the electronics, what they do is very similar to a cyber attack. It's like I said, the way to combat this new asymmetrical warfare that we see emerging is disrupt their networks or disrupt their electronics. And we're using cyber to do that. Predominantly is how we're doing that. And what our attack does is it basically moves in through the skin of the drone or skin of the USV. You know, we can affect any kind of electronics, consumer electronics, or even other kinds of electronics we have effects against. And it goes right in, gets into the analog portion. And for those that are a little more technical out there, it goes up against op amps and other things that do kind of comparisons, and they do comparator op amps and things, and it'll just mess up the inputs. For example, that's one example. It'll just mess up the inputs where both are high. They're 1 and 1 all the time. And then that confuses the machine, and the machine goes, what's going on? I'm not getting the right instructions, and shuts itself down. And then it just shuts itself down. Now, if a drone shuts itself down, it falls 500 feet out of the air and crashes on the ground and breaks. But a boat motor, if we take a boat motor out, outboard boat motor, that'll be able to start back up again once you turn off the energy. So under the energy, it won't work, but with the energy not applied, you can start the boat motor up again. So it does sort of a light kill, called level 4 kill, versus a heavy one where you'll damage the equipment or the electronics completely. So that's the basics down now in the weeds of how the electromagnetic interference gets into the system, and then once in the system, performs some kind of a cyber attack in order to disable it.
Wow, that is way different than I was expecting. I was expecting it's like putting metal in the microwave. It shorts itself out.
Sparks and shorts and stuff. No, it's much more sophisticated than that. Yeah, it's a more sophisticated set of techniques that are, you are hinting at, like you can pick a lock with some of these things. It's exactly right. You know, there are locks to be picked, just like in electronic warfare. There were a number of different counter radar techniques that we could employ. Well, the same idea goes with this type of system. It has a lot of sophistication to the waveform that applies different techniques on different systems.
That's pretty cool. All right, Andy, we're going to mix it up here. The tech's cool. You're a veteran. I'm a veteran. We've both been out there on the mission. So you and I both know that there's way more to the tech when you're out in the field with the warfighter. It has to fit into the bigger picture. So let's talk about not just the technology, but how we actually integrate it into the operations and tactics. And the reason I want to spend some time on this is there is a YouTube video that came out recently. It's got like 14 million views. It's like one of the top 5 YouTubers on the internet. And they did a recent interview with Palmer Luckey, great guy, fan of the merge, I hear. It was talking about their Anvil drone interceptor, which is a kinetic kill. So it's a drone going after a drone. Pretty cool tech. I've got to be honest. It's pretty cool. But when they were editing the video, the way that he framed the problem, it's problem framing, 101 is you oversimplify why everything else won't work. And then you focus on your pitch, right? He said there's 6 ways to defend against drone attacks. They all have a major flaw. And I want to get your take on this, because he said something to the effect of high-powered microwaves are great. That thing might be effective at 2,000 meters. All I have to do is go get some cheap copper tape, wrap the drone in some copper tape, and now it's basically only effective at like 2 meters. And so the copper tape renders the entire Leonidas product useless. So I'd like to get your thoughts. Again, we're all professionals here. This is serious business, and we know it's not that simple. Can you elaborate on that?
Well, I'm a mixed mind. At one side, I say, yeah, that's exactly how you defeat our system, China.
China, please do that. Just please do that.
Maybe Palmer was on a deceptive mission there, where he would say, hey, all you got to do is wrap your drones up with some copper tape and you're good to go, China, and then we'll be laughing. Ha, ha, ha. That's what they think is going to work. It's funny. I don't want to talk too much about how to defeat our system for obvious reasons.
Oh, yeah.
Right?
Yeah.
But, obviously we work in electromagnetic interference energy or electromagnetic pulses. And, people study even nuclear-derived EMPs that can hit the ground. And there's ways to shield against that. They're called Faraday cages, for example, where you have 6 sides of metal around something and then that metal box grounded to earth ground. And that's one way that you can basically get a lot of that electromagnetic interference and just shunt it to ground, basically short circuit it to ground. And so in his explanation in that video, he was indicating kind of that approach. It's like if you can take a shield and wrap the entire drone in the shield of tape, then you can ground that to some drone ground, because you can't obviously get earth ground because you're up in the sky, but to drone ground, and then shunt all that EMI away and it won't get into the system. Now, here's the problem with the Faraday cage. You open up one little door. Let's say you have a big room that's a Faraday cage. You open up one little door, boom, it's done. It's not a Faraday cage anymore. It does not work like a Faraday cage. So all of these drones require penetrations. They require propellers, they require engines, they require other things that protrude outside of somewhere where you could create a Faraday cage. And those holes actually are quite convenient for us, because we can tune our back end, get in through one of those holes, and stay inside a lot easier. Once we're through, we get inside and stay inside. So what we found in studies, and that's not just me, this is ONR and another of people that have done studies, guess what? With copper tape. So ONR has tried this exact experiment. And, if folks want to, if they're on the military side, they can contact ONR and get the real results of what really happens when you try to do this. But the short answer is it completely doesn't work at all. It fails mightily in doing any sort of real protection, the copper tape against our system. And in fact, by doing it in a kind of a unknowledgeable way, you can make matters worse for yourself. You can actually make the system more susceptible to our type of energy and therefore be able to be affected at a further distance away. Not in all cases, like we've done our own experiments where we've done a really solid job of putting copper tape every little square millimeter on the system, and we still couldn't see any measurable difference between a drone without any copper tape on it and with copper tape.
Wow.
But if you're in China, do the copper tape. That'll work. Or Iran or Russia or whatever.
I appreciate the technical insight. I saw it on YouTube and I was like, copper tape? Like, I don't know. Like, I don't know anything about what he was talking about. So, yeah. But at the end of the day, though, it's not an either or, it's a yes and you know this from being in the military out in the field. Like, there is no magical solution for anything, right? Everything that has a capability has a limitation. And what you want is you want a force structure or a force design. So you have a protection layers, in this case for defense, where you are playing strengths against weaknesses, and wherever you have a weakness, it is augmented by something else that has a complementary strength. And so the collective system is stronger than, the sum of the pieces, right? So the two that come to mind for me, for those that may not be thinking of like, how does a HPM maybe how integrate into the force? The first one is AIMD, Integrated Air and Missile Defenses. This is a layered approach where we have fighters doing defensive counter-air, and they're one of several pieces of layered defenses. So we have layers of fighters going out long range, then medium range. Then we have layers of ground-based air defenses, medium range and short range. And then we have close-in weapon systems for that kind of end game glove save. But if we just had one of those systems, none of it would ever work. You have to have all of it, and they all have to be there in a time and a place, and they're complementary capabilities. The other one that comes to mind, which is maybe a little bit more obvious, is ballistic missile defense. Like, what an important mission. And you look at the technical strategy of the United States, there is no one system that can do that mission. They are all designed and optimized to do parts of the mission, and then they work as a system as a whole to provide the mission, ballistic missile defense. And I would assume that the Army is caught on based on the program that you're involved with, the IFPC, indirect fire protection capability.
Yeah, IFPC-HPM. Yep.
So IFPC-HPM is one of several parts of that that program. It's a portfolio where it has, if I remember right, it has 3 parts to it. There's the 3 effectors. It has an interceptor, which I think is a ground launched AIM-9X or a Tamir missile from an Iron Dome. Then it also has a high energy laser, IFPC-HEL. And then you have Leonidas, which is IFPC-HPM. So we have 3 different types of effectors for this indirect fire protection capability. I would presume that the Army is coming up with a very similar kind of layered onion nested strategy for defense with these systems, right?
Oh yeah, absolutely. It's a very important point to point out. Like, and we kind of have a little tongue-in-cheek, a little fun with Palmer and that video that was purposely simplified. It was for younger audiences and folks that were completely unfamiliar with this type of stuff. So I think, like you pointed out, Palmer was trying to be purposefully simple in the way that he was trying to describe things. But in seriousness, this is going to be a multi-effector type problem to solve. So if you look at today, what's going on the Army side and on the requirement side, they are the ones chartered with base defense. So you think of like an airfield or something like that. They're the ones they're the service that is chartered to go protect that with the air defense and all of that. And they look at it as a big air defense going all the way out to the horizon or beyond the horizon. And there are layers all the way in until you get to what's called the short range air defense layer. That's where we're talking about not really having air dominance, is in the short range air. And where that's happening is these little mosquitoes are flying under all of our systems and all of our detection systems, but our effector systems, and they're getting in underneath. And if you look at it today, somewhere around 10 kilometers or around 5 miles, 4 or 5 miles, that extend out from a base or some fixed asset. You got a lot of discussion, right? We're not quite sure what One, what are all the different mission scenarios, right? Like what will the drones do, or what will the air vehicles do? Will they pop up? Will they zigzag? Will they come in low? Will they come in two different angles at a whole bunch of them at the same time? Sometimes it's an ISR mission. So there needs to be some amount of detailing of the different scenarios, the threat scenarios that the warfighters are seeing or anticipate they're going to see. And then from there, you need to start drawing doctrine inside of those lines, inside of that pie. That one pie is like not good enough for a layer. There are layers within that layer. In fact, our particular system is called the fire protective fires layer. So we're the final dome, the final, just going back to the Star Trek analogy, we're the final shield.
Instantly what I thought of was like shields on, and if you get the hordes, you try to attrit them at range and you thin the herd. So then the shield has a manageable problem to protect as that last layer of defenses, right?
It's electromagnetic energy that's not designed to go way out, but it's designed to fill a big volume of air with tons of persistent energy in order to stop any number of things that got through. Sort of like your hockey goalie, at the very end to just protect that goal. But outside of that final hundreds of yards, if not kilometers, couple kilometers, whatnot, outside of that, you still have the need for lasers, the need for kinetic sort of rival drones like the Anvil drone and other systems that Anduril's bringing to bear. All of those things work in harmony, and Anduril has a great system called the Lattice system that's designed to coordinate all those systems, that's designed to know when to hand off and when to assign a threat here and a threat there. So in fact, Anduril knows very well that this is a layered defense problem. This isn't one piece of the pie. There's multiple layers of this even short-range pie that we need to figure out as both an industry partners and the government, the DoD. I don't know that today you can go to anyone, all the way up to the very top guy in all of DoD and say, tell me what the doctrine is for short-range air defense. Tell me how we're going to fight this fight. There's not a lot of answers that I've been hearing. I've been hearing a lot of like, yeah, we need to get on that. We need to figure out what that looks like.
That's SHORAD is one of the first things that got cut when the global war on terror happened. The Army started divesting all of their systems. They started with the kinetic effectors, then they got rid of the radars, then they got rid of the people, and so there was probably like a 10-year gap where there was like nothing happening for short-range air defense, and really the only thing that kept people alive was hope. You hope that no one was going to start something, and when things in Syria started happening. We had a few close calls of people being attacked by the air, and I think that was the wake-up call. And things have happened more recently in Jordan, which just proves the point of like, hey, we got caught blindsided here by taking our eye off the ball. And so never waste a crisis. So there's huge opportunity here.
Right, exactly.
And I mean, make light of it. It is a serious business. And, being the goalie and a defensive system, your defensive system for protecting against a threat to people's lives. So I don't want to make light that it is a very serious business, and being like the last line of defense is got to be something that I'd imagine like your employees, come to work with that in their mind every day.
Oh, yeah. Our tagline is innovate with impact. And we believe at Epirus that national security and defending a world of freedom is an impact cause. And a lot of our investors think the same thing, that they see what we're doing and what we're trying to change and sort of the talent and the culture of our company. And they say, you know what, I'd really like to put my money to work. This is such an important problem. A lot of our young daughters and sons are out there. We have a board member named David Kim, who's a very successful man, but graduated from West Point early in his career, Army, has 3 kids in the military. He sits on our board for that reason. This is personal. His kids that are in these bases in Tower 22, it's children out of America that are over there fighting the fight for us. And they deserve to be protected. To the best of our technology, we'll be able to protect them. So it's a super, super meaningful cause. Purpose for me, a mission for me to protect. I've done that for a while. I've done a number of companies at Raytheon to protect, but then to really help the DoD protect well against this asymmetrical emergent problem. And that's the thing they're not doing well today that Epirus hopes to improve with the DoD for the future.
Well said. Now, a couple more things I'd like to hit on, then I'll let you go. we talked a little bit earlier about being able to speed ahead of need for the Department of Defense and moving faster than them. But ultimately, you do have a government customer with a product that goes out and does things. And so there's other parts of the government that have to be sticking points, to say it lightly. And I would imagine because you're radiating like the FCC or the FAA, trying to get this thing into partners and allies' hands, export restrictions, like what are some of the pain points that you see from that? You have something that's so far ahead of the government. How do you, which may not even, I don't even know, does high power microwaves even have like an ITAR restriction?
Oh yeah.
Oh, it does. Okay.
Oh yeah. Yeah, they do. Written in circa 1991. And so that's actually,
oh man,
you've hit on a buzz, like right on the buzzer on this one. I mean, yeah, there is a lot of lack of coordination cross-departmentally, right? You have the DoD who have advocated the adaptive acquisition framework, which was designed to build, capability that we don't have, that we desperately need. We have people dying like, let's say, circa early 2000s in the IED, and how we responded as a nation. We did respond. We went MRAP at 180 million, 170 million in 2006 to 16, 17 billion in 2008. I mean, we responded as a nation to that crisis. This is another new crisis that we need the DoD to respond to, and they are. They're doing it at the pace that they've been chartered to do it. Congress thinks they should go faster, but they're moving at a hell of a clip. But to your point, we run up as a commercial company all these bumpers that we can't get around, like ITAR. ITAR right now, we're completely restricted. I think AUKUS and some other programs like that are going to give us some light at the end of the tunnel. But up until now, our international business has been completely restricted by old policy written in 1990 called an NDP-1, and that had been written in 1990 around the area of HPM and directed energy. And those updates are long in the tooth to be made to kind of give us the permission to start working with our allies, like the UK and Australia and others like that, that are right there at the enemy line, that could use a system like ours and keep us utilized, well utilized. While the Army delays, we can fill in those lumps. It is a big problem. The FAA is a problem as far as them not having any active policy on how to declare an emergency against drones, and say, hey, this is like a NORAD issue. If you think about it, if it was a Soviet MiG that came into the airspace, it would be NORAD. If it's even a Cessna with a bunch of bombs strapped to its belly that came into an airspace, it would be a NORAD issue. But a drone with a hand grenade on it, somehow it's nobody's. Like nobody understands where to really go with that kind of a toy. So we have an asymmetrical problem that permeates not only within the DoD, but they're at least at it and trying to work on it. You got the FAA that I'm not sure are at it, trying to work at it. I see a lot of delays every time I talk. In fact, I asked the FAA recently about a person that might be able to be the system engineer that could even do the safety analysis on a system like ours that knows the microwaves and all of that. They said that position's not filled presently. They don't even have anyone. So I am troubled by the lack of coordination of Homeland Security, DHS, and Border Patrol, that sort of folks, and then along with like stadium protection, civil protection. We've got critical infrastructure sites, Department of Energy protection, all of that stuff. None of them have gotten the memo. None of them have gotten the memo that these drones are a problem and are going to be a continual problem, both overseas and domestically. Unfortunately, if something were to happen domestically, they would all wake up, I'm sure, in a second. But today, there's a lot of hand-wringing and not a lot of movement in an aggressive way towards a domestic sort of strategy against these types of threats.
One of the helpful things in industry or in the commercial sector that the Pentagon and Congress doesn't really spend enough time on is they try to war game things and like, is this going to happen? What are the odds of that happening? Let's do the ops analysis. You can just skip to the good stuff and go, let's just do a pre-mortem.
Yeah, exactly. That's a great point. That's a great point.
What if a quadcopter with a grenade happened to blow up a plane at DCA, right? At the Ronald Reagan Airport, which is like right by the Pentagon, Congress, and just flew up there, blew up, took out a plane, and there's a hearing. and everyone's like, oh my God, what happened? How did we not know this? FAA, what's going on? DOD, what's going on? And everyone, and you highlight this issue. Like you don't have to wait for the thing to happen to do that. Well, let's assume it did, God forbid, in this hypothetical scenario. And they say, hey, Andy, we need to come to Congress, this hearing, and we want to hear your thoughts. And they say, Andy, you have a magic wand. What is the first thing that you would change, like this week, and then like the next month, and then next year? What are the first three steps on those three horizons that we need to do as a government to like help us protect ourselves against this threat? What would you say?
There needs to be a special forces group, like, you call it a RCTO, Army RCTO, Rapid Capabilities and Critical Technology Office. They are a special forces, if you will, when it comes to quick acquisition. They have smart acquisition people like General Rash, who's done this over and over, understands the system backwards and forwards. And then he's then chartered with this special forces mission to get a warfighter a capability they need. And he's thinking, bases and overseas, so FAA and all that. Well, I'd say that the FAA needs a special forces group. I'd say the FCC needs one. I'd say Homeland Security and Border Patrol. And those special forces groups need to work in concert with one another. They need to have, like in Team of Teams, General McChrystal,
Oh, yeah.
They need to swap people in and out of their different, you go work FAA, you go work DOD, so on and so on. And they need to build that. That's a warfighting mentality right there, that they're going to prioritize speed and decision-making over safety and security. Not that they're not going to have safety and security in their charter, but you're going to swing the pendulum over a little bit to speed and delivery versus safety and security with that special forces group that's cross-departmental. And it could even Department of Trade, so on and so on. I think we really need to build what the DOD has started. That's the only way that I see that a coordinated effort could be done at a national level. So I'd say that's kind of the first and most important thing. And then the second thing is always what comes next is once the decision makers are there and the policy writers are there, then it comes the money. And the issue with the money is that it's all programmed for big war, post-World War II type programs. It's all 3, 4, 5 years in advance. You might have an idea. You've got to get an idea out there 5 years, and then you'll have money, not the thing 5 years later. You'll have money to go make a thing. So it's like years between having the need and the capability to even going to start making the thing.
For people who are unaware, to your point, we're recording this, and we're recording this in the end of May of 2024, the Pentagon is about halfway through building their 2027 budget.
Correct.
So there is no money
Correct.
in 2025. There is no money in 2026. So if something happened today, the process would be in 2027, like we'd have to program the money like, 2.5, 3 years ago for it to happen. So it's
exactly.
It's a very archaic process.
Now, to the DOD's credit, they're putting programs into place. So I have to give all my brothers and customers and sisters over there their due. They have something called AppFit. They have something called Raider funds. They have something called DIU. Okay, all of these organizations, and now the CDAO office, okay, they all have large in-year or 1-2 year out programmable pots of money, but I still think it's, for this type of asymmetrical war, it's not enough. It's still not enough. An AppFit is around $200 million. DIU got a big increase this year. They went from 150 million to 950 million. So they're starting to get that idea, but the more that we can put in sort of this reprogrammable pots that we keep sort of unallocated so that it can be positioned and then allocated or appropriated based upon in-year really, really urgent emergent threats. I think more of that needs to be had.
I want to switch gears. I want to switch domains, actually. We talked about the FAA, been talking about drones in the air. Way back earlier in our discussion, you'd said something about boat motors. So are you, let's talk about that. I want to unpack that because, there's not just drones in the air, there's drones in the ocean. And for those who have been tracking the Middle East for a while, like Iran has had swarming boat tactics in the Straits there for a long time, call it 15 years, 20 years. And that's been a big problem. Could high-powered microwave disable some of those boat motors? What are you guys doing with that?
We have this little Honda 90 horsepower outboard motor that we show taken out at distance. And this summer, there's a Navy effort going on called Antex, ANTX. We're bringing out a modified system, a system for the Navy, specifically built out for the Navy, in order to run against a whole host of different boat motors, outsourced boat motors, just to see what kind of effects we have on a broader range, a much broader range. We're going to see against a lot of different things. So we're a little earlier in our phasing than we are with the Army and the counter-air, counter-drone, but we are just as effective against boat motors, for example, as we are against drone motors. Or we even work against automobile motors. We work against anything that has power in it, really. Laptops and switches and night vision goggles, anything that you can imagine that you need electricity and electronics to operate, which is just about everything these days, we have a potential effect on. So yeah, boat motors are next in line. And that one is bigger than even the USVs, because you have a really interesting application against drug boats and pirates. You know, pirates were big when we were in the service. We had the coal incident. And when that all happened, people are like, what to do about this? Well, here it is. Directed energy, beam a beam right at that boat motor, shut her down. If it turns out it's just some vacationers, once you remove the energy, the boat gets back going again. You don't need to damage the boat motor or any of that. You can just turn it off when we shine our light on it. And then when we turn the light off, it goes away. And because the system is such a high peak to average power ratio, our average power is quite low. So your microwave oven has a equal average to peak power ratio. It's a lot of average power, meaning like a lot of power distributed over time continuously. Our system peaks and then rests, peaks, then rests. You know, very quickly it does this, but by doing that, it causes a low average power, which is the part that hurts humans. On the electronic side, you're not worried about heating up molecules. You're worried about disrupting kind of clock signals and things like that that happen at a much quicker kind of pulse type of a way. So you can combat that with the pulses like we do versus having to go to like a larger CW system. So it's safe. It's human safe. It's safe on electronics for the most part, as far as when you turn it off, it doesn't damage them. So what a perfect system to put out there and help police the channels against not only swarms of boats, but pirates and drug runners and all that, the Coast Guard mission and so on.
So you have a Leonidas ground to air. You're experimenting with surface to surface with the Navy boat motors now. You're off the coast of California this summer. And do you have an airborne variant as well? Did I see that right?
Well, we have some ideas anyways, and we've been talking with the Air Force. I can't say a whole lot, but we are experimenting with some ideas around an airborne version as well. In sequence order, it kind of goes ground, sea, air, as far as where we are is how far along we are in each of those categories. Yeah. But it works. You know, it's just a matter of size, weight, power, moving it on to this platform or that platform, finding the right applications. It just works against all kinds of threats. So I think we're going to find we're at a tip of an iceberg. You know, recently in the news, and in fact, we have some folks from the UK MOD visiting us just tomorrow. They put out something similar in the news, that they have their own high-powered microwave phased array-looking weapon system just recently.
I saw that.
This isn't going away. People are going to have PhDs in this area of science. This is deep science that we're imparting upon these consumer systems. Deep science that's going to have, I think, a plethora of different activity, study. We are at Epirus maybe out in front of most, but we are barely scratching the surface. It's a fascinating time to be in the field of electronic warfare.
Well, I was hoping, Andy, to end on a good note by giving you the final thought of like, hey, where do you see this technology in the next 3 to 5 years? But you kind of already answered that. So instead, where do you see Epirus in the next 3 to 5 years?
Well, if things go according to the plan that we're on here, we have a mighty tiger by its tail, and the timing is about everything for us. I mean, a mighty tiger by the tail, and the timing is everything for us, meaning our timing is now. It is our moment. It is our moment. We have a very, very robust program that we're building with the Army that will transition to missiles and space as a program of record. If we do everything well, like we've been doing, so far so good, it will transition around that 2027 timeframe is what we're targeting at least. Hopefully, maybe we can even pull that to the left. We stand ready to pull it to the left if the Army gives us a sign to go quicker. And then we have a number of program of records we see beginning to emerge both on the Navy side and the Air Force side that I can speak less about. But we see ourselves as having 2 or maybe even 3 program of records that include IFPC HPM, Mobile SHORAD, potentially the Navy program that I was speaking about before, and then also some Air Force work that will be largely probably S&T for the next couple of years. Well, once we get to that point and we have our international plan fixed and sorted out, we'll start to be working into domestic applications by then, I'd guess. And I think would be a good time to maybe take us public, because we'll have a large basis, we'll be profitable in a few years, and we'll have the need for more free capital so that we can do the right acquisitions and get ourselves placed in these other applications, both internationally and domestically. And I think that would be maybe a good plan for me to take us public in about 3 years or maybe 4.
Not to have the last word, because I don't want to take anything away from what you just said, which is amazing. But some people may get the impression it's kind of hypothetical, like visionary. But you guys have a massive factory in California now to scale production. Like you are putting all the pieces in place to manifest, that destiny that you just kind of laid out, right?
Yeah, we built our proverbial gigafactory, I guess, for these systems. We have a capacity to do about 40 systems per year in California. So if that big of a demand hit, 40 systems per year isn't going to be enough when we're at scale. So we have a very strong relationship with the folks in Oklahoma, and we plan on building in Southwest Oklahoma, basically our larger production facility. And that's coming next. We're in the very early days of planning and what that looks like and how to sequence that. As everything, you need to plan this stuff 2 or 3 years in advance, so we're getting out ahead of it. So yeah, we look at the future, and we're happy to be partners with Oklahoma. Oklahoma is really a very, very strong counter-drone and drone state. Both OSU and OU work in that area as centers of excellence. They have some of the best in the world, basically. And so a lot of centralization in Oklahoma is sort of occurring around the drone and the counter-drone space. Of course, you got Fort Sill there, where a lot of the operators with the Patriot missile MOS will likely be the operators that operate our system as we get further down the road. So we're looking at Oklahoma as another launch point for us in those 2 to 3 year time frames. But yeah, it's been a real whirlwind of fun. A great mission. I love what I'm doing. I love my job. I don't tell my investors, but I do this for free. It's so much fun. I enjoy my everyday getting up and coming to work. I enjoy the people I work with. If you walk around the walls and halls of our facility, you see, a Fourier, transforms and, calculus equations and stuff. It's just an amazing people, an amazing place to work. I love it. I really, really love it.
Exciting times, exciting technology, man. What a great company. Next time I'm out in California, I'm going to have to drop by and check out the situation you got out there.
Please check out our situation. Yeah, it's great. I'll tell you, we're right near the airport too. Not only about 5 miles, 6 miles from LAX, so it's not a hard stop by if you're here anyways.
I will take you up on that offer. Where can people learn more about Epirus and check out what you guys are doing?
Well, come on over to our website, as we all say, www.epirusinc.com, and find out lots more about high-powered microwaves and what Epirus is doing to advance that whole technology.
Awesome. We're going to put that link in the show notes. And if you've been watching this on YouTube the whole time, we've been splicing in all the goodness that you see from their website and their YouTube channel of the Leonidas directed energy weapon in action. And for those who are just listening to this, go to the YouTube channel. You're missing out. There's a lot of good stuff. This is real. It's real cool, and it's happening. Andy, thank you so much for your time. CEO of Epirus, out there doing great things.
Thank you, Mike.
Until next time, we'll see you.